That feels better. Okay, here we are. It is currently Tuesday, October 6th, 8:25 in the morning, getting ready for the day. I wanted to make this video for you today for those of you that need to stay home or have to be at home for whatever reason. I've made video 1, which was a lot of basic matrix things, adding matrices, scalar multiplication, finding determinants, stuff like that. This video today is going to be a little bit shorter because first of all, I'm not sure exactly how far we're going to get in class today because I've got a few other things that I'm going to do in class. But if I make this video go into the next big topic, then this video is going to end up being really long, and I don't want that. So I'm going to kind of cut it a little bit shorter here and then start the next video with this, this next topic that's going to take a little bit more time. So let's just get into it. If you don't remember where we left off, or maybe if you didn't watch the last video, or you didn't need to watch the last video because you were in school that day, then I'm going to go ahead and share with you where we're at here. And first of all, I need to focus this thing. So let me see if I can get it focused here. That's not bad. Okay. So we are in chapter 2. Of course, you know that. If you don't have your chapter 2 notes, they are available in the chapter 2 folder. We're talking about matrices. And last time, let me make myself a little bit bigger here. We just learned about rows and columns for matrices, square, column, and row matrices. We learned how to add and subtract. We learned what an additive inverse matrix is. We set up numbers from a problem, from a word problem in a matrix. We learned about scalar multiplication, what a scalar was. We learned, well, we didn't really learn what a determinant was, but we learned how to find determinants for 2x2 matrices and for 3x3 matrices. And that's the last thing we did, was to learn the determinant of a 3x3 matrix. So ready for this next page, which says using technology. So we are from time to time going to be using our graphing calculators to do some stuff with matrices. I am not going to go through that right now because different people might have different calculators and it would be a waste of time for them, and I don't know what that situation is. So that's something that you'll need to get with me in class, either whether it's a time that we have work time in class or you want to come in during SRT or before or after class, something like that. And I can go through and show you how to do these things on your calculator. It won't take long. So we're going to skip that for now. We're going to move on to multiplying matrices. Now I want to contrast this with scalar multiplication. What we're talking about here is not scalar multiplication. Remember that scalar multiplication meant multiplying a matrix by a scalar. A scalar could be the number 3 or the number -2. Remember, in this case, we just multiplied all these numbers by -2. I didn't do this one, but if I did, I would just multiply all the numbers in that matrix by 3, because 3 is a scalar. That's scalar multiplication. That's not what we're doing here. What we're doing here is multiplying 2 matrices together. Okay? So we're going to do 2 matrices together, and our answer now is going to be another matrix. So we're going to do some examples on the other side, and there's kind of a worked out example here for you. I'm not going to be going through that with you. You can read it if you want to. There's another worked out example here for how we do that. And then there's some problems on this page and the next page where we're going to walk through how to multiply 2 matrices together. You can see here that we're multiplying one matrix by another matrix. Before we do that, there's some kind of pre-work that we need to do here. So first of all, not every matrix can be multiplied by every other matrix. There's just some matrices that can't be multiplied together. And I wanted to show you what situation has to occur in order to be able to multiply the matrices together. So we've got this little example here, and this says, let's say we're multiplying 2 matrices. One matrix is matrix A, the other matrix is matrix B. Let's suppose matrix A is a 3x4 matrix, which means, as you know, that it has 3 rows and 4 columns. And let's just pretend that matrix B is a 4x1 matrix, which again, as you know, means that it has 4 rows and 1 column. You'll notice that this arrow here is kind of comparing these two numbers, and this thing that these must match is referring to those middle numbers. So in order to be able to multiply these matrices together, those middle two numbers have to be the same. In other words, the number of columns in A has to be the same as the number of rows in B. In this case, they are, so we would be able to multiply these matrices together. If those two middle numbers are not the same, then you cannot multiply those matrices. So that's number one. The second thing is that the outer two numbers, this 3 and that 1, will tell you the dimensions of your answer. So I know when I multiply these two matrices together that my answer will be a 3x1 matrix because of this 3 and this 1. So my answer is going to have 3 rows and 1 column. And that can be really helpful when we're setting up and actually doing this problem. So if we look down here, it says A is 4x4 and B is 4x2. So I like to, and by the way, this 2 right here got moved down to the other line. This 2 right here was supposed to go right up here. So I'm going to move it there, and then I'm going to wipe this out so it doesn't get in the way. Okay, so if A is 4x4 and B is 4x2, I'm asking, can I do this product? And if so, what would the answer be? So you see how these middle two numbers are the same? That means, yes, we can multiply these matrices. Okay, we can multiply them. What would be the dimensions of our product? Well, for that, we use the outer two numbers. So our product would have 4 rows and it would have 2 columns. It's going to be from that 4 and that 2. Okay, and we need to know this before we can actually start multiplying them together. So in this case, A is 3x1 and B is 3x1. Well, you see how those two middle numbers are not the same? That means we can't even multiply those matrices together. So don't waste your time trying. Same with example C. If A is 2x3 and B is 1x2, well, those middle two numbers, the 3 and the 1, are not the same, so we cannot multiply them. But that is only if I do matrix A times matrix B, which is all I did in the other ones, because I was just going to wait till now to make this point. But I want you to notice what would happen if I try to multiply matrix B times matrix A. Now, I am not saying that A times B is the same as B times A. Usually that's been the case, right? 3 times 5 is the same as 5 times 3. That was called your commutative property. Well, turns out the commutative property doesn't hold for matrix multiplication. So you'll see what happens here. If I do B times A, B is 1 times 2, but A is 2x3. Well, looky there. Now my middle numbers are the same. I can multiply these matrices, and my answer will have 1 row and 3 columns. So A times B and B times A are not the same thing when A and B are matrices. In fact, in this case, we can't even do A times B, but we are able to do B times A. Okay, again, there's some kind of examples here. There's some examples down here. We're going to do some of these, but I really think that the best one to start with is example C on the next page, because it's 2 square 2x2 matrices. And this is kind of the simplest one to learn with. It's the simplest example to learn how this works, because this is not necessarily difficult, but it is a little bit tricky. There's a lot of moving parts here. So first of all, I want you to notice that our first matrix is 2x2, and our second matrix is also 2 rows and 2 columns. So our two middle numbers are the same. The 2's in the middle are the same. So we will be able to multiply these. And when we do, our answer will have 2 rows and 2 columns. So our answer is also going to be a 2 by 2. So I'm going to set up here just kind of a blank 2 by 2 matrix that's going to have 2 rows and 2 columns. See it? 1, 2 rows and 1, 2 columns. And let's see if we can find the number that's going to go in this blank, which is in the first row and the first column. In order to find the number that's in the first row and the first column in our answer matrix, we are going to multiply the first row and the first column of these 2 matrices. So I'm going to do the first row multiplied by the first column. Now you might be asking yourself, how am I going to multiply a row by a column? Let me show you how that works. We're going to start with the first number in the row and the first number in the column. It's the 2 and the 7, and I'm going to multiply those numbers together. So 2 times 7, that's 14. Then I'm going to go, and this is the tricky move here. I'm going to move across the row and down the column. So again, I started with the 2 and the 7. I move across the row and down the column. Now I'm looking at this -1 and this +1. And if I multiply those together, I get a -1. So I multiply the first numbers together, then I move across and multiply those second numbers together, and ultimately I'm going to add those products. And we'll do that in the next step. Okay, let's see if we can find the number that's going to go in this position, which is in the first row and the second column. Since the number I'm trying to find is in the first row and the second column, then I'm going to multiply the first row times the second column. So I'm going to start at the beginning of the first row and the beginning of the second column, and I'm going to multiply these numbers. So 2 times 3 gives me a 6. Then again, we're going to do our slide move where we're going to go across the row and down the column. So we start at the beginning of the row and the beginning of the column, and we slide across the row and down the column. Now I'm looking at the -1 and the -4. And if I multiply -1 times -4, I get +4. And again, in the next step, we're going to add those numbers together. Let's move on to the next one, which is in the second row and the first column. So I'm going to be multiplying the second row of this matrix and the first column of this one, because that's the position of the number I'm trying to find. It's in the second row and the first column. So I'll multiply the 3 times the 7, which is a 21. Then I'm going to slide across the row and down the column. Now I've got a 6 and a 1, and I multiply those, and that's a 6. And in the next step, I'm going to add those together. Finally, the only number we don't have yet is in the second row and the second column. So I'm going to multiply the second row times the second column. So the number at the beginning of the row and the beginning of the column is a 3 and a 3. Multiply 3 times 3, and that gives me a 9. And then I slide across the row and down the column. Now I have a 6 and a -4. Multiply those, and I get a -24. And again, I'm going to want to add those. Okay, my last step is just to add all these numbers together. So 14 minus 1 is 13. 6 plus 4 is 10. 21 plus 6 is 27. And then 9 minus 24 would be -15. No, it's not. Yes, it is. That's right. Okay. So that's the idea of multiplying matrices. We're multiplying rows of the first matrix by columns in the second matrix. Now keep in mind here that sometimes you might be asked to multiply matrices that you can't multiply together. For example, in example F, this first matrix here has 2 rows and 3 columns. And then the matrix we're multiplying by also has 2 rows and 3 columns. And you'll notice that those numbers in the middle are not the same. We can't multiply these. So one like that, you just say, that's not possible. We can't do that. That's the only example on this page, though, that is not possible. I'd like to go back to the previous page where there were some simpler ones down here, and we can go to example A. And the first thing I want to do is just make sure I can multiply these together. So the first matrix has 2 rows and 3 columns. The second matrix, if I look horizontally, has 1, 2, 3 rows, but just that 1 column. So that's 3 by 1. Okay, my numbers in the middle are the same. That means I can multiply these matrices. The numbers on the outside will tell me that the dimensions of my answer here are going to be 2 by 1. Okay, so I'm going to go and multiply these together, and I know that my answer is going to have 2 rows and 1 column. So it's going to have 2 rows and 1 column. Let's do it. So to get this answer here, this is in the first row and the first column. So I'm going to multiply first row times first column. So start at the beginning, 2 times 2, that gives me a 4. Then I'm going to move across the row and down the column. Now I'm at a 4 and a 3, that's a 12. Then I'm going to move across the row and down the column. Now I'm at a 6 and a 4, that's a 24. And again, we're going to add all of those together. Okay, then I want the number that is in the second row and the first column. So I'm going to multiply the second row and the first column. -1 times 2 is -2. And I'm going to go ahead and put my plus here because now you know that we're going to add. I'm going to move across the row and down the column. 3 times 3 is 9 plus. And then across the row and down the column, 0 times 4 is 0. And now all we have to do is add these things up. 4 plus 12 plus 24 is 40. -2 plus 9 is 7. And there's my answer. I'll go ahead and let you do example B. And then I'm going to already have my answer worked out here. So go ahead and do example B. Pause this video. 3, 2, 1, pause. Okay, so you should have finished example B now, and your final answer should be this matrix that's a single column, 10 and -1. All right, let's go on and do 1 or 2 more here on this next page, and then you can practice on the rest of them. So let's try example E, which looks like it's a little bit more complicated. This one, the first matrix has 3 rows and 3 columns. The second matrix has 3 rows and 2 columns. So that's a 3 by 2. I look at my middle 2 numbers and I see that they're the same. That means that this product can be done. And then I look at my outer 2 numbers and I see that my answer is going to have 3 rows and 2 columns. So my answer here is going to be a 3 by 2 matrix. Let's go ahead and do it. Okay, a 3 by 2 matrix is going to look like this. 3 rows, 2 columns. You don't have to set this up with the empty spaces like that every time, although some people like to do that. I think it helps for me to explain as we go through here. So we're going to start with the number that is in the first row and the first column. So I'm going to multiply first row times first column. I've got a -2. Move across and down. Now I've got a 3. Move across and down. Now I've got an 8. Okay, it's up to you whether you want to do, if you want to move down next or if you want to move over next. Doesn't make any difference. I like to go over next. So this number is in the first row and the second column. So I'm going to multiply first row, second column. So I start at -1 and 3. That's a -3. Move across and down. That's 1 times 2. So that's a 2. Move across and down. 2 times 5 is 10. Okay, now I'm going to go to this number, which is in the second row and the first column. So I'm going to be multiplying the second row here times the first column here. Start at the beginning of this row and the beginning of this column. 3 times 2 is 6. Across and down, -2 times 3 is -6. Across and down, 1 times 4 is 4. Okay, this number would be in the second row and the second column. Second row, second column. 3 times 3 is 9. Across and down, -2 times 2 is -4. across and down. 1 times 5 is 5. We've got one more row to go. Now we're in the third row and the first column. Third row, first column. Okay, 4 times 2, that's 8. Slide. 5 times 3 is 15. Slide. 2 times 4 is 8. Finally, third row, second column. Third row, second column. 4 times 3 is 12. Do your slide. 5 times 2 is 10. One more slide. 2 times 5 is 10. And now we just have to add all these numbers together. So -2 plus 3 plus 8, that's 9. -3 plus 2 plus 10 is 9. 6 minus 6 plus 4 is 4. 9 minus 4 plus 5 is 10. 8 plus 15 plus 8 is 31. 12 plus 10 plus 10 is 32. And there we go. So we've done 2 of these. Why don't you take a break here? There's only 2 more on this page left. That would be example D and example G. Why don't you go ahead and do those 2 examples, pause the video while you do that, and then when you unpause, I'll have my answers up here, and that'll be the end of it, okay? So let's pause in 3, 2, 1, pause. Okay, you should be finished with example D, and your answer should be this matrix -2, 10, 0, 8. It's just a 2 by 2 matrix. If you missed that, I've kind of got my work shown here. Hopefully I didn't make any mistakes. And you can check and see where your mistake might be. In example G, wow, look how big that answer is. That's if we do a 3 by 1 multiplied by a 1 by 4. You can say the middle numbers are the same, and those outer numbers are a 3 and a 4. So that gives us a 3 by 4 matrix. When you do this, when you get that number in the first row in the first column, it's just this 3 times the 2. That's the 6. And then we stay first row, second column would be 3 times 4. And then first row, third column would be 3 times 6. And then first row, fourth column would be 3 times 1. So this 3 here is the first row. It's the only number in that row. And then you go 2 times 2 is 4, 2 times 4 is 8, 2 times 6 is 12, 2 times 1 is 2. And then 1 times 2 is 2, 1 times 4 is 4, 1 times 6 is 6, 1 times 1 is 1, and that's a little bit tricky. Okay, guys, this next section is where we start the part of this chapter that's a little bit more in depth, even though I know multiplying matrices was a little bit complicated, but hopefully you did okay with that. So I'm going to stop this video here, and that's it. I will see you either in class or in the next video. Goodbye.